Compound gear ratios. A compound train, gear train once again, has two gears on the same axle. So if you look here at the blue and orange gears, they're both mated to the same axle. So, if we were asked to find the gear ratio of the entire train, if this was just a regular gear train, you could just take the number of teeth on the out, divide it by the number of teeth that's the driver, and you're finished. But if it's pardon me, I messed up my recording. If it's compound, then it's not so simple. We got to figure out how these gears are put together to figure out all the ratios that we have to find. So you start out with the driver. The driver is attached to B. So we got to first figure out the gear ratio of A to B. Once you get on B, the teeth of B are not on any other gear, but C, which is mounted to B on the same axle, it has a relationship with another gear, C and D, that is. So we have to find the gear ratio of C to D. So A goes to B, then C goes to D. Once we find those ratios, then we can find the ratio of the entire train. Once again, gear ratio, one of the definitions, is the number of teeth on the out divided by number of teeth in, out over an in. The driver here is A, 10 teeth. What's being driven from A to B is B, which is 40 teeth. That reduces to 4 to 1, or 4. From C to D, C is the driver, it's in. D is the driven, it's out. So once again, every time we use this, we use the formula. Number of teeth on the out, that's D, is 50. Number of teeth on the in, that's gear C, which is 20. It reduces to 5 over 2. So the entire system has a gear ratio of, you have to multiply these gear ratios together. So we're going to have to multiply 4 times 5 over 2. A little cross-canceling here. 4 divided by 2 is 2. 2 divided by 2 is 1. We have 2 times 5, which is 10. 10 divided by 1, which is 10. The gear ratio is 10 to 1. You don't have to write the 1. If it's a 1, it's implied, but you could write it 10 to 1, or you could write it 10 to 1, either way.